When you're ready.
Stem cell therapies by Brady and Aidan.
We both researched, I researched the economic lens, and Brady researched the futuristic lens. The first thing we wanted to talk about was just what the world currently looks like and lay the groundwork for moving forward. So current medicine, stem cell therapies are currently deemed as almost always experimental. Bone marrow transplants are the only kind of stem cell therapy that are FDA approved and covered by insurance. And then moving forward, the success rate of stem cell therapies. So a Louis A. Kona, a PhD in orthopedic, states that basic treatments for immune systems and blood disorders has a 60 to 70% success rate. Now this success rate can change based on the kind of treatment. In treatments for cases of autism, they can see 95% improvement in function, and in other treatments such as organs and other things like that, it's way lower and sometimes hasn't even been tested in a clinical trial. The current cost of stem cell therapies ranges anywhere from around $5,000 to $50,000. These prices are extremely high, and most of the time they're not covered by insurance. This makes it extremely difficult for the average person to receive this medication, and it makes the world of improving stem cells much more difficult.
How they're currently made? They're currently made using some sort of usually blood and then a chemical reaction, and then they're hand sorted by a researcher or a scientist hand sorts them and then takes the usable stem cells for the transplant.
So this is a graph showing the current size of the stem cell banking market. A team of President's researchers states that from 2023 all the way to 2033, we'll see an average growth of around 15%, and that'll go all the way until we reach around $25 billion in 2033. This growth is extremely beneficial towards the entire topic of stem cell therapies. Even though it just shows the banking area, we can see that this growth will in turn result in more research and more improvements in the field. And moving forward, currently there are some current economic problems with stem cells and how they work. So the first thing we all read about in this class was that New York Times article, and one of the main key points of that was how they have contamination in areas where there shouldn't be contamination, and even sometimes in the embryonic stem cells, they have leaky bags, so that it's just unreliable. It said in the New York Times article, it stated that in January, inspectors found the Food and Drug Administration inspectors found troubling signs of bacteria growth at CBR's Seoul warehouse in Tucson, Arizona. And that's extremely bad for the stem cell field. The next problem is high prices. I stated earlier that it can cost anywhere from $5,000 to $50,000, and not being covered by insurance extremely limits it. And unreliable withdrawals. So in stem cell banking, they are placed into cryopreservation, and it currently says that that has no significant impact on the viability of the cells. But as we read, when you're trying to withdraw those cells, sometimes there's not enough, or contamination can occur. And then moving on to stem cell therapy problems. So as we talked earlier, no insurance coverage. This means it's an extremely unrealistic option for the average human. And as well as we're going to see inflation with that graph moving up, the prices of those stem cell therapies will most likely move up as well, and create an even bigger gap from the average person being able to afford this. And the last problem is a lack of real world trials. In today's world, we see minimalistic real world applications for most stem cell therapies, and it's going to hinder the growth of the field. And then the futuristic possibilities. So currently I talked about how banks are using cryopreservation. In the future, that could be the same case, but we can also see banks that have, they're called nurture tanks or whatever you want to call it, but it would ensure the safety of those cells and hopefully eliminate bacteria so that even if your embryonic stem cells do get contaminated, they can clear out the bacteria and ensure the viability of those cells.
Factories, as I said earlier, they're currently hand sorted and then use it with that chemical process. If we have factories, machines can make the process much quicker by using micro lasers to quickly eliminate the unusable stem cells and then move them into transplant. That'll allow us to not have, as Aidan said, hopefully the stem cells will cost less because we won't have to pay anyone. And then drug testing. Drug testing can become a lot easier because we can use stem cells, we can use a bottle or a form of stem cells, inject the drug and then test it, and that'll show us your body's reaction or your most likely reaction. Same thing with clinical trials as well. We can move clinical trials much faster because we'll have the drug, because we can use stem cells. So you can use, let's say it's a new medicine, you can mix the stem cells and the clinical trial medicine together and see what the reaction would be. And then curing incurable diseases. Stem cells have the possibility to cure many incurable diseases using just the process of them reforming it. A lot of them is organs. So let's say you have type 1 diabetes, you can reform the pancreas and then help it can start producing insulin again. So here are 4 main ones. We have type 1, as I said. Type 1 diabetes can be cured by reforming the pancreas, and then that will allow it to reproduce insulin. Bone marrow transplants is the only current FDA-approved way. It's currently being used in many hospitals to cure types of cancers. Spinal cords, there's been multiple cases where people have been paralyzed and then they've used stem cell therapies and rebuilt the spinal cord and they've been able to walk again. And then organ regrowth, any type of organ that has had damage to it or lost function can be regrown using stem cells. In conclusion, they're currently not super reliable, but they do have a ton of possibilities in the futuristic aspect, and they're currently extremely expensive, and they could cure incurable diseases. So currently, stem cell therapies are not super effective, but they have the possibility to be groundbreaking in the medical field.
All right, Aidan. If you had another team member, what other perspective or limitations could they have researched that would have made a useful contribution to your project?
I think the scientific lens could have really helped both of us. We both had to spend a lot of time diving into that scientific aspect of it ourselves because we didn't understand a lot of it. And I think if we had another group member, their contributions could have been more towards that scientific idea, and then we could have expanded more on the futuristic and economic lenses and made a broader, had more knowledge.
Okay, all right. Brady, reflecting on Aidan's work, what kind of an impact did it have on your overall understanding of the problem?
It made me look at the economic aspect more, especially the futuristic. So one of our slides, it was the futuristic and economic combined. So it kind of showed what the path would be towards pricing, and then it made me kind of think are they effective economically right now? What's the price like that? Will insurance ever cover it? Made me look at a few different questions that I wouldn't have originally thought of.
Okay, all right. Another round of applause.